Hi, my name is Randy. I'm an application engineer at Keysight. Remember when wideband CDMA was considered wide, which had a channel bandwidth of 5 MHz? Today's modern communication systems are using bandwidths in excess of a gigahertz. Take, for example, 802.11ad, which has a channel bandwidth of 2 GHz. In the future, 802.11ay will have even wider bandwidths through the use of channel bonding. Even 5G is using wider modulation bandwidths. Everybody wants to have higher data rates to the end user, and one of the ways this is being done is through the use of wider modulation bandwidths at the microwave and millimeter wave frequencies. Today I'm going to show you a demo using our AWG and UXA to generate and analyze ultra-wide bandwidth signals. Let's take a look at the demo setup. We'll start with the M8195A arbitrary waveform generator. This has a sample rate up to 65 gigasamples per second. This enables us to generate signals that have a bandwidth in excess of 10 gigahertz. In this demo, we're going to generate an IF directly centered at 5 gigahertz with a bandwidth of nearly 10 gigahertz. This will be the input to our upconverter. We're also using a MXG signal generator as the LO. This gets mixed with the IF to produce an output at a frequency of 83.5 gigahertz. The output of our upconverter goes through an amplifier to increase the signal level, and then the output of the amplifier, we go from a waveguide to coax transition, and then we go into our UXA signal analyzer, the N9041B, which has a frequency range from DC all the way to 110 gigahertz. The UXA has an internal digitizer that can digitize signals up to a gigahertz in bandwidth. But because we have a signal that's nearly 10 gigahertz wide, we're going to take the IF output of 5 gigahertz and use that to drive one of our wide bandwidth oscilloscopes, where we have the VSA software running, which will do the demodulation for our demonstration. So let me show you how we generated the signal for this demo. We're using our IQ Tools application, which comes with the M8195 AWG, to generate our wide bandwidth signal. First, we're going to set the symbol rate to 7.1 gigahertz. We'll set the modulation type to 16 QAM. We'll set the filter to a root raised cosine filter with an alpha of 0.35. And then we'll set the carrier offset to 5 gigahertz. So this will give us a 16 QAM signal with a bandwidth of nearly 10 gigahertz centered at an IF of 5 gigahertz. Once we're satisfied with the settings, we press the download button. It gets downloaded into the AWG and begins generating the signal. Now that we've generated the signal, let's take a look at the spectrum on the signal analyzer. We're making a swept-tuned measurement of our spectrum coming out of the upconverter. On the screen you can see the upper and lower mixing products of the LO and the IF. The signal that we're actually demodulating is centered at 83.5 gigahertz. The UXA has several band breaks over its frequency range, and because of this, the specified bandwidth of the analyzer is 5 gigahertz. However, at many other frequencies, the bandwidth is much wider. In fact, you can see today we're generating and analyzing a signal that's 10 gigahertz wide at 83.5 gigahertz, which is in the lightly licensed E-band region. Now we're going to demodulate the signal and look at the demodulation metrics. To do that, we're going to use our VSA software. In the upper left screen, you see the constellation diagram, which shows the 16 QAM signal. In the lower left screen, you see the spectrum, which shows nearly a 10 gigahertz bandwidth. And then if we look in the lower middle screen, we can see the EVM, which shows an incredible result considering the very wide modulation bandwidth that we're using. Then in the upper right part of the screen, we see the overall channel response from the equalizer, and in the lower right, we see the CCDF curve. The flexibility of the VSA software enables a large number of other traces and metrics to be displayed, depending upon your specific requirements and device under test. If you're an R&D engineer working on ultra-wide bandwidth communication systems, consider Keysight's off-the-shelf solutions with capability up to 110 gigahertz. For more information, visit us on the web. Thanks for watching.